Okay, we're going to look at solving multi-step equations today. So this is more than two steps, like we talked about last time. So it'll be an added step, maybe combining like terms or distributing before you do your inverse operations. And there could be um, more than two inverse operations even when we involve fractions, like we saw on the flowchart. So, solving an equation after combining like terms. If you recall, like terms are terms that have the same variable to the same power attached to them. If it's a constant, that means there is no variable attached to it. This would be an example of a constant right here. So, what we want to do is combine like terms, and I'm going to add to that on one side of the equation. So I'm not referring to inverse operations and combining those like terms when I add or subtract something to each side, but what I'm referring to is looking at one side of the equation, like this one right here, or when we get to two variables, we'll look at both sides separately. So we might look at combining like terms over here separately. Notice that there's only a 5 over there, so we're not going to worry about that. But when I say combining like terms, I mean just on one side of the equation, collecting all those terms together that are like terms. So we have the constant, that is the 23, right here. There are no other constants or no other numbers without letters attached to it on the left-hand side. So we're not going to combine any of those. But what we will see here, let me erase this, is two terms with an x attached to them. And so we want to take those two terms, the 5x and the 2x, and combine them together. And the way we do that is we add or subtract, depending on the sign that is attached to each of the like terms, the numbers out in front. So we have 5 plus 2. We're going to add those two together and then just attach an x. And so what we end up with is 7x, and then we just copy down the minus 23. So that is the idea of combining like terms. So we may be asked to do that first before we then use our process for two-step equations. So now, from the other day, we're going to look at this, say, okay, we need to add 23 to each side first. So 7x equals 5 plus 23, which is 28. And then the final step here is going to be the inverse operation of multiplying 7 times x is to divide by 7 on each side. We have canceling here to equal 1, so that is 1x on the left-hand side. That's our goal. And 28 divided by 7 is 4. Let's go ahead and box our answer. Let's check it. So here's what the check would look like. The check now becomes a little more important. It's not something you can necessarily do just mentally by looking at it. So we have 5, and then in place of that first x, we're going to put a 4 minus 23 plus 2 times 4 equals 5. And so we have 20 minus 23 plus 8. Question is, does that equal 5? What we can actually do is just work with the left-hand side. Let's just keep working with that. We're going to see if it equals 5. So 20 minus 23 is negative 3 plus 8, which is 5. And so it does check out. So that's combining like terms first. All right, problem 2. We are going to use the distributive property before solving. And here's what the distributive property says. It says if we have a number or letter outside of the parentheses and two terms or more inside the parentheses, we've got to make sure we multiply that term outside the parentheses by each and every term inside parentheses. And in this case, then we have negative 8, and we're going to multiply that by 2x, And we also have, let's put a plus sign here. Now, we'll talk a bit about that in a minute here. We have plus, negative 8, and then I like to think of this minus 1 as a negative 1. And then I can go ahead and leave this plus sign right here. So we can always just carry the sign with the number like I did here and separate the two terms that we get when we distribute with a plus sign. So that's what distribution looks like. Something we've seen before, you've seen before. That's what's going on there. So now we're going to do the multiplication. Most students will do this multiplication in their head and not write down this step. So you might jump from the original problem to negative 16x. Negative 8 times negative 1 is positive 8 equals 36. And then now we're, like we were up above, back to a two-step equation. And so we're going to use our inverse operations now. My whole point is we need to take care of combining like terms, or a lot of students will do the distributive property first. I'm going to show you another way to do this as well that relates to our flowcharts, but this is probably the most common thing to do, especially if there is more than one distribution that has to take place within an equation, which is what we'll see on our skill test. Let's finish this off. Subtract 8 from each side. So a negative 16x, this is canceling to equal 0 here. So those are gone. Just leaving negative 16x. 36 minus 8 is 28 here. And when we divide 28 by negative 16, we get x equals, and this one, I don't want you to panic here, we have a fraction on this one that we're going to get. There are two ways to write the fraction. We could simplify it and leave it as an improper fraction. Notice that both of these are even, so I could start cutting them in half. Perhaps you see that 4 will go into each one as well. If I were to cut these in half, half of 28 is 14, half of 16 is 8, so we have 14 over negative 8. We can then break that down even more to 7 over 4. And the negative sign right here makes the whole fraction negative. So we have x equals negative 7/4. We could also write this as a mixed number. Negative 4 goes into 7 once with 3 left over, so 1 3/4. Okay? So I don't want you to think that every equation has an integer solution. An integer is a positive or negative whole number. It's okay to get a fraction. And especially with the use of our calculators, it's fine to do this division and then change it to a fraction, or to write it as a mixed number would be fine to do as well. Let's go ahead and do the check. The check is difficult when we have fractions involved, but it can be done. So I'll show you what it looks like. We have negative 8. We have 2 times negative 7/4 is probably entering it in as a improper fraction, it's probably easier. And then minus 1. And we'll see what that equals. It should equal 36 here. So when we go to do this, we have negative 8. We're going to do what's in parentheses first. We're actually going to work on the multiplication first. You could use your calculator to do 2 times negative 7/4. Or you can multiply 2 times 7 is 14 over 4. 14 over 4, negative 14 over 4. That ends up being minus 1. And we can simplify that to negative 7 over 2 minus 1. And so to think of this, there's a couple ways to think of this. You can go ahead and, on your calculator, plug in negative 7 over 2 minus 1. Another way to think about this is as a mixed number. This is negative 3 1/2. minus 1. That might be another way to think about it. Move this over. So this would be negative 8 times negative 3.5 minus 1 is negative 4.5. And if you do negative 4.5 times negative 8, you should get 36. I could enter this into my calculator as negative 8 times negative 4.5, or you can do so just using your ABC key on your calculator. But negative 8 times negative 4.5 is 36. Alright, I want to show you one other thing here. What we were doing on flowcharts is we were asking the question, what is the equation here? What's happening here with x? We were kind of building the equation first, and then doing the inverse operation. So I want to just show you how that might work here. If I were to take x, I would be multiplying by 2. Then I would subtract 1. And then there's a third step in which I am multiplying by negative 8. Now, I can take 36 and create a flowchart for this and not distribute first. As a matter of fact, according to the flowchart, the first thing I would do is not distribute the negative 8, but I would actually divide 36 by the negative 8, because the inverse operation of multiplying by negative 8 is to divide by negative 8. And so if I took the, well, let's just do the whole flowchart. Then to get rid of the subtracting 1, I would add 1. And then to get rid of the multiply by 2, I would divide by 2. Let me demonstrate this flowchart on my graphing calculator. Pause this for just a moment. Pull that up. Okay, so on my graphing calculator, I would do exactly what it said here. We had a flowchart that says take 36, divide by negative 8, then we're going to add 1, then we're going to divide by 2. So let's go ahead and do that. Remember, my answer here was x equals negative 7/4 or negative 1.1 3/4. If you were to write that as a decimal, it would be negative 1.75. So you notice here, let's see what we get on our calculators. Let's simple that as well. Alright, so going over to my calculator, I have 36 is what I'm starting with, right? I'm going to divide by negative 8. Hit enter. Get negative 4.5. Okay, the next thing I was asked to do is add 1. So I divided by negative 8 first. Now I'm going to add 1 right here. So over here, add 1. My answer, hit enter, and there's negative 3.5. Then the next step is to, right here, is I'm going to divide by 2. So I'm going to go over here to my calculator, and I take that answer and divide by 2. What I get? Negative 1.75. So there isn't just one way to solve this equation. You could distribute first, and I would encourage you to do that. The reason for that is if there's more than one set of parentheses in a problem, which will happen on our skill test, it's best to distribute first, then collect like terms like we did in problem 1, and then solve it using your inverse operations. But this is not the only way in which you can solve the problem. It is okay to divide each side by negative 8 first, as we did with the flowchart solution. You need to understand that when it comes to solving equations, there's more than one way to get the same answer. It demonstrates it. So let's go on to the next one here. It says solving an equation that has variables on both sides. Here we go. So now we have one that does have variables on both sides. And in our practice, we may not even get to this today, but I have another practice worksheet that we'll get to where we'll be dealing with some with variables on both sides. That's our ultimate goal here. But it's still the idea that you're going to combine any like terms you see on each side of the equation separately. So, when I look at this left-hand side, there aren't any like terms here yet. I actually need to distribute first. Look at the right-hand side. You can see here and here. Neither of these are like terms. So we don't have any like terms to collect just yet. After distributing, sometimes you'll end up with like terms to collect. But let's go ahead and distribute. So 2 times negative 3x is negative 6x, and 2 times negative 2 is negative 4. This equals negative 4x plus 4. So that's the distributive property, multiplying the 2 by each of those. Now, we can look at each of these separately. Here's one side. No other like terms here. The x term and the constant are not like terms. Also looking over here, there are no like terms on either side. So what we have here is variables on both sides. We can go ahead and now start using inverse operations to solve. What I typically suggest when we have variables on both sides is to go ahead and get the variable on one side. Using inverse operations. Okay. So you can actually get it on, some students like to get everything over to the left-hand side. Some students and teachers have taught to try to make the number in front of the x positive. If you look at this, we can do either. If I decided to get everything to the left-hand side, which seems to work fairly well with a lot of students in this particular class, we would then add 4x to each side. Then you have a consistency here. We're just going to move all the x variables over to the left. Negative 6x plus 4x is negative 2x, so I'm only adding the 4x to the x term because they are like terms. I do not add the 4x to the negative 4. I just bring that down and copy it. And then I have over here the negative 4x and the 4x cancel, leaving just 4. And so there it is. I've got the x term on the left, and I'm ready to solve my two-stepper here. So I add 4 to each side. I have negative 2x equals 8. And then I divide by negative 2, and x equals negative 4. So that is my solution. I could check it in there, see that it works. Now, let me just demonstrate to you that had I gone a different direction in that first step, remember when I had negative 6x minus 4 equals negative 4x plus 4, I had stated that some students like to get a positive term in front of their x over here. If I had started here with adding 6x to each side, let's just see what happens. So these would cancel to equal 0, leaving just negative 4. These two like terms, negative 4x plus 6x, would give me 2x. And now, once again, I'm left with a two-step equation to solve for x. I would subtract 4 from each side to give me negative 8 here. And then finally divide each side by 2. And you'll notice that I once again get x equals negative 4. So I went a different route with that. But using my inverse operations correctly, I get the same solution. Now, that isn't the only way you could go about it. You could have actually decided to, at this point right here, add 4 to each side. Or you could have even subtracted 4 from each side. There are many different steps you could have taken. A lot of students, just for consistency's sake, do like to maybe get all the x's to the same side to the left side. It seems to work pretty well within this class in Algebra 1 and a beginning algebra class. All right. Last problem here. It says solving an equation that contains fractions. What is the solution of? Okay, so we got some fractions in here. You can see on this side over here we have a fraction attached to x, and then we have a constant. So there are no like terms to combine there. We're going to have to deal with that fraction in a minute. Over on this side, you can see that there are some like terms to combine here and here so that we have just one single x term and one constant. So I have one x here, another x here. That gives me 2x minus 6. I'm just going to copy down the left-hand side. Now, if I want to get the x's all to the left-hand side, it's going to involve subtracting 2x from each side, and I'm subtracting fractions in this case. So what I would encourage you to do is on your calculator, let's go ahead and subtract these two fractions. If we can do it, we'll think about it a couple different ways, but if I take 3 divided by 2, and you're going to use the ABC key here, so 3 over 2, and then I am subtracting 2 from it, minus 2, and that gives me negative 0.5, so it's like taking 1.5, is another way to think about that. 3 over 2 is 1.5, minus 2 gives me negative 0.5, or as a fraction on your calculator, it popped up as negative 1/2. And so I have on here negative 1/2 x minus 4 equals negative 6. And then I'm going to go ahead and just do my two-step equation process here, adding 4 to each side. I'd really encourage you to go ahead and use your calculator on the fractions that show up in these algebra problems. You can also change them to a decimal or a mixed number. If you can do the fractions by getting common denominators, go for it. But we don't want you to miss, just a moment here, we don't want you to miss the problem or the algebra because you made a mistake on the arithmetic with fractions. So it's okay to use your ABC key on here as we're going through these types of problems. So negative 1/2 x equals negative 2. And then if you'll recall, when we have a fraction in front of a variable, we solve by multiplying each side by the reciprocal.
Will the following students...
All right, so now you multiply each side by the reciprocal of what's in front of x. So it's negative 2 over 1. And on the other side, the same thing, negative 2 over 1. You can see here that these two fractions will cancel out to equal 1, leaving me with just x. And then over here, if I multiply straight across, if you'd like, you can put a 1 underneath the 2. Negative 2 times negative 2 is 4, and so I get x equals 4 as my solution. All right, that's it for today.